Hello guys, here is a detailed explanation about UPSC Geo-scientist Geology and Hydrogeology paper. Here is the first question 101. The variety of banded iron formation present in Archean greenstone belt with Gravex volcanic association in North. Here are four options are given. First we have to let's know about what is banded iron formation. Banded iron formation is mostly formed between 3.8 to 1.8 billion years ago. The composition of banded iron formation is alternating layer of iron and iron minerals such as hematite, magnetite, combined with silica, chert, and jasper mineral. They are typically formed in ancient oceans. Here you said the banded iron formation present in Archean greenstone belt with grave eggs and volcanic association. So here is the answer is B, allogama type. The allogama type is typically associated with volcanic and grave egg sequence in greenstone belt and believed to have formed in relatively shallow marine environments. Okay, we have to discuss on the other type of iron formation. The bog iron type is formed in bog or swamp through chemical and biochemical oxidation of iron carried in solution, typically composed of iron hydroxide such as geotide, and can also include magnetite and other iron minerals. The bog iron ore typically form in swamp through the oxidation of iron in groundwater. The composition of primarily iron hydroxide, commonly geotide, and may include magnetite. Is naturally so. Next one is Clinton type of iron deposit. They are typically is a type of ironstone deposit. Is characterized by oolitic texture. It means contains small rounded grains or oolites composed in iron minerals. They typically found in shallow marine environment, and these are primarily composed of hematite with some siderite and some mosite minerals. The structure is oolitic with small rounded grain iron minerals. It typically forms shallow marine environment, often associated with sedimentary rocks. Next type of is superior type. Superior type is formed during Proterozoic. They typically found on stable continental shelves and characterized by large size and extensive lateral extent. They are formed during 2.8 to 1.8 billion years ago. Formation environment is stable continental shelf and composed of hematite magnetite with alternating layer of iron oxide and silica chert. Size is large, dimension often greater than 100 meter in thickness and extending over 100 kilometers. Okay. Next. Okay, next question is 102. Which one of the following statement regarding supergene enrichment process is not correct? Here are four statements are given. Pyrite breakdown into produce insoluble iron hydroxide and sulfuric acid in the oxidation zone. Yes, correct. The soluble metal in the upper part of sulfide ore body are generally leaching down to the water table. These are correct. Supergene environment take place below the water table. No, is the incorrect. Usually the supergene environment is above to the water table. And the nature of hypogene mineralization has no bearing on supergene enrichment mineralization. This statement is also incorrect, but we have to choose only one statement. Which one is mostly perfect? Which one is correct? We have to choose any one option. The D option is also incorrect. The nature of hypogene mineralization can influence supergene enrichment mineralization as original composition affect metal are mobilized and redeposit. We are supergene enrichment. First we go to little bit study about supergene enrichment process. is involved. It involves the chemical alteration and concentration of valuable metals in ore deposit through the actions of descending meteoritic water derived from precipitation. The process are oxidation, leaching, and precipitation. The oxidation event nearly occur this surface. Meteoritic water oxidize primarily hydrogen sulfide ore. The oxidation process produces sulfuric acid and dissolved metals. Next process is leaching. Leaching this the dissolved metal ion are carried downward by percolating groundwater. As the water move through oxidized zone, it contributes to dissolved and transport metals. Next process is precipitation. When the metal reach groundwater, the reducing condition below the water level, the metal precipitate and form secondary sulfide mineral. The result in the enrichment of ore deposit at the base of oxidized zone. The supergene enrichment is particularly significant in copper ore deposit, where it leads to the formation of secondary copper sulfide minerals such as chalcocite, cobalt, and others. Next question is, which one of the following indicate the temperature range in degrees Celsius for formation mesothermal deposit as defined Lindgren deposit. Okay, we have to just know what is Lindgren classification of ore deposit. It's based on temperature and pressure condition. Here we have to divide ore deposit into four main categories. First one is telithermal deposit, is epithermal deposit, mesothermal deposit, hypothermal deposit. First one is second, the telithermal deposit usually less than 50 degrees Celsius, very low pressure nearly surface, example fluorite and barite deposit. The second one is epithermal deposit, is nearly temperature 50 to 200 degrees Celsius. This comes under epithermal. Pressure is low, nearly shallow depth. Examples of gold, silver, and mercury. So here is the answer is, here they are asking formation of mesothermal deposit. Mesothermal deposit are usually form under 200 to 300 degrees Celsius. Moderate pressure, intermediate. Example gold, silver, and base metal. The last one is deep seated temperature is greater than 300 degrees Celsius is hypothermal deposit. Is, for example, tin, tungsten, and molybdenum deposit are occurred. Next one is consider the following statement regarding lateritic deposit. What is laterite? First we have to know about laterite is type of soil and rock formation rich in iron and aluminum, formed mostly in tropical and subtropical region through intense weathering of underlying rock. The weathering leads to the leaching of soluble minerals, leaving behind insoluble oxide of iron and aluminum. The result is characterized reddish color of laterite. This mostly shows rich in iron and aluminum. Other contains goethite and hematite and gypsite. This color typically reddish brown due to presence of iron oxide. We also know that the laterite are typically formed in dense weathering and typically tropical and subtropical climate, leading to leaching of soluble metal and concentration of iron and aluminum. First we got to comes to the topic question. There are two statements are given. First one is laterite is the product of intense weathering in humid, warm intertropical region and can divided into ferruginous and aluminous variety. Ferruginous means iron rich, aluminous means aluminum rich. So first statement is correct. The second statement, the accumulation of an aluminum rich residuum as opposed to iron in lateritic profile is a function of higher rainfall and lower average temperature. This statement is also correct. The accumulation of alumina over iron laterite profile can occur region with higher rainfall and somewhat lower average temperature. Thus, the condition favor for the leaching of iron and relative enrichment of aluminum. So, both statements are correct. Let's move on to the next question. Consider the following statement regarding gas hydrate. Gas hydrate, we all know, is a cathode hydrate, or crystalline solid composed of water and gas molecules. These mostly contain resemble ice but contain significant amount of gases, typically methane. These hydrate are formed under specific conditions with low temperature and high pressure, commonly found in marine environment and very cold regions. Okay, let's come to the there are two statements are given. Gas hydrate or crystalline aqueous compound that form at low temperature when ice lattice expand to accommodate a variety of gases molecules, most important of which methane. Which is methane? Yes, this statement is correct. We also know that gas hydrate include methane hydrate form under low temperature and high pressure. They consist of crystalline structure of water molecules that enclose gaseous molecules, primarily methane. Second statement is gas hydrate will melt if either temperature increases or pressure decreases. Yeah, this statement is also correct. Gas hydrate are stable under specific condition, low temperature and high pressure. If the temperature increases or the pressure decreases, the gas hydrate will desiccate, releasing the trapped gas molecules and melting the hydrate structure. Okay, this is this gas hydrate is also important in it's also important questions. Okay, next one is the rank of coal depend upon which one of the following factor. Okay, we are here as 4 days. 4 options are given: degree of metamorphism, climate condition of coal formation, place of accumulation, source of material. We also know the coal is ranked based on degree of transformation from peat to anthracite, which determine factors such as carbon content and the presence of impurities and the calorific value. Peat primarily okay, we know peat. Here is the answer is degree of composition, degree of metamorphism. Metamorphism is changing temperature and pressure condition. We also know peat contain very low carbon content. Mainly peat is very low carbon content. Compare is most highest is anthracite is higher carbon content, nearly 90 to 98%. Anthracite coal are hot, glassy black coal with highest calorific value and lowest moisture content, as compared to peat is very higher moisture content and decomposed plant material with low carbon content, mainly used as soil conditioner and fuel, some etc. Okay, next. Okay, next one is match list 1 with list 2. Okay, we neglect this question. We move on to the next 108. Which one of the following main reservoir of Mumbai offshore basin? Yeah, Mumbai offshore basin is Bombay Basin, significant hydrocarbon producing region located in western continental shelf of India. It extends from Saurashtra Basin in northwest to the Kerala Konkan Basin in south, covering an area of nearly 1,16,000 square kilometers. The Bombay offshore basin is a cratonic rift basin situated on the western continent margin of India, formed due to extensional tectonic activity during separation of Indian plate from Madagascar in the early Jurassic and late Cretaceous period. And age and sediment thickness, the age of the basin ranging from late Cretaceous to Holocene. The sedimentary fill thickness is 1,100 to 5,000 kilometers. So, is the most first the main reservoir rock of Mumbai offshore basin is mostly carbonate. Okay. Because it contains limestone. Okay, we got to move on to the next question. Which of the following conditions are required for flowing well in aquifer condition? Aquifer, what we know, aquifer is underground layer of water bearing permeable rock, sediment or soil that can store and transmit groundwater. Okay, we know the we have to classify the aquifer in two types: unconfined and confined aquifer. Unconfined aquifer means an aquifer with upper surface open to the atmosphere through permeable rock or soil. It directly reached by surface water. The confined aquifer is a sandwich between two layer of rock or sediment that prevent direct recharge from the surface water within the confined aquifer under pressure. Here is an artesian well. It is if well is drilled into confined aquifer, the water may rise above the aquifer level without pumping due to pressure creating an artesian well. So here is some four options are given: overlying impermeable layer. Yeah, this ensure the water is confined under pressure. So second one is underlying impermeable layer. This ensure the water is contained within the aquifer. The third one is potentiometric surface above the ground surface. The fourth one is potentiometric surface below the ground surface. So the in 3 or 4 the correct is 3. The potentiometric surface above the ground surface. This allow the water to flow out the well without pumping due to pressure in the confined aquifer. So 1, 2 and 3 is the correct. 3 options are correct statement. Next question. In an area of 1000 meters square, the water dropped by 4 meters, assuming the aquifer to be homogeneous and isotropic. If the porosity of the aquifer is 30% and the specific retention is 10%, the estimated change in groundwater storage would be, we got to calculate the groundwater storage. Here to estimate the change in groundwater storage, we can use the formula. The change in groundwater storage, it's equal to area into change in water table into specific yield. Okay, here is an specific yield. We got to determine the specific yield. Okay, is porosity minus specific retention porosity. Okay, we got to calculate first one is specific yield. How to calculate the specific yield? Porosity here is 30% minus 10% equal to 20%. We got to write in 0.20. Okay, we got to multiply to calculate the change in groundwater. We got to multiply the 1500 meter square into 4 meters into 0.20. This is the specific yield of the yield is 0.20. We have to calculate we get the answer is 8000 meters square. First we got to know how to calculate the change in groundwater. The formula is to calculate change in groundwater storage is area into change in water table into specific yield. We know the area and water table change is 1004 meters, but we got to calculate specific yield. They are given in porosity and specific retention. To calculate this specific yield, we got to porosity minus specific retention is our specific yield. Okay, next move on to next question. Okay, which if your rock has 50% porosity and 30% specific retention is the specific yield. We also discussed in an above one question where is simple. The specific is calculated by subtracting specific retention from the porosity. So here is porosity is 55% minus specific retention is 30%. We get the answer is 25%. Okay, let's move on to the next question. Consider the following statement regarding hydraulic conductivity of an aquifer. It depends on dynamic viscosity of the flow. This statement is correct. Hydraulic conductivity is influenced by dynamic viscosity of the flow of the fluid flowing through the aquifer. Next one is it depends on the aquifer property. This statement is also correct. The hydraulic conductivity depends on property of the aquifer such as size and arrangement of force, grain size, distribution and permeability. So here is the second statement is also correct. The second statement is also correct. Next third statement, it does not depend on density of the fluid. Is also it depends on the density of the fluid. The statement is incorrect. So 1 and 2 is the correct answer. The statement 3 is hydraulic conductivities can be affect the density of the fluid. Okay. Okay, move on to the next. Okay, we discussed only 12 questions in this session. We will see. Okay, this rest of 1 to 15 question is there. Okay. Okay, we will discuss later. Bye.